Good morning, ladies and gentlemen. It's our pleasure that you all guys are here to update and share the HVAC technology all together. I am Jaruwat Senior Customer Application Engineer, who is responsible for the heat pump application. Today, the topic is the knowledge that can support the SCI compressor in heat pump application. I will start with the performance improvement by discharge speed control first. What is the discharge speed control? How to use it? And then we move to the thermoacoustic shell. It can make your heat pump more quiet as you are well wished. And finally, the pipe recommendation we will talk about to finish your pipe design. So you no longer to worry about the piping crack anymore. And let's get started with the discharge superheat first. Conventionally, the suction speed control is the well-known controlling method in the refrigeration system. It must be controlled more than 0K in practically way 5 or 10 to be ensured that 100% of refrigerant gas will be entering into the compressor. As we all know, at this point, it doesn't get the full performance of the evaporator, but to playing around this situation is too risky. How can we do? We would like to recommend our new friend, discharge superheat control, which is the unique technique which is available for SCI compressor. For the discharge speed control, we change the control from the suction side to control at the discharge side. It can improve the reliability and performance as well. As long as you can keep the discharge superheat value more than 10K, liquid back situation, liquid back portion can be allowed even if the suction superheat is 0K without any trading of the reliability issue. And it can get more efficiency as well. I will show you. The discharge speed control is the controlling method to improve to optimize the flow for the evaporator. As you can see here in the pH diagram, when the flow of the evaporator is optimized, it's increasing, and you will get a heating performance as well. What about the result of the discharge speed control when applied in the heat pump application? This is the air-to-water heat pump following the EN 14825 regulation with the fixed water temperature 35 degrees Celsius. And the improvement compared to suction superheat 8K at the low ambient temperature. The efficiency improvement is up to 15%, and in the high ambient temperature is up to 4%. In the same trend as well for Brine to water heat pump at the same condition, fixed water temperature 35 degrees Celsius. And compare with the suction superheat 5K, in the low ambient temperature, the efficiency improvement is up to 25%, and in the high ambient temperature is up to 15%. Well, how about the seasonal performance of the European climate zone? I do a short summary for you. Here, this is the SCOP improvement for the Brine to water heat pump. It's improved plus 15% for average climate zone and cool climate zone. And for air to water heat pump, in average zone is around 2%. It's almost 5% for cool zone. Here, you can see that the discharge speed control can enhance your heat pump efficiency and keep a good reliability as long as your heat pump lifetime. For the next one, I would like to move to thermoacoustic shell. the sound level is one of the most important things that we have to concern. That's why we do our thermoacoustic shell, and it can reduce the sound level as much as 10 decibel, which will get more comfortable, more quiet, especially for residential use. And it has additional function. It can reduce the heat loss of the heat pump as well, as much as 10%. And you are right, you will get more heating capacity. Finally, it's about the pipe recommendation. We have an expert team to list policy for this issue. Especially, we can recommend how to design the pipe for your heat pump. We can recommend, we can support the pipe design for you as well. And we also have the simulation software to simulate, to find the critical point, like the resonance, the maximum stress in your pipe design. And we also confirm with the actual test by the vibration and state machine. This is our support for you to make you more confident with our solution. For the next session, it will be Q&A. You can drop your question here at your chat box, and my team will pick some interesting questions.
Wow, that was a wonderful presentation. Thank you for such a clear explanations on the discharge superheat control concept. So we will go with the first question here, and it's quite straightforward. So how to find the suitable discharge superheat value?
Okay, the discharge superheat value depends on the condition and also in each unit. On the high compression ratio, it has a high value of discharge superheat more than low compression ratio. You have to vary the discharge superheat value to find the base COP of your system. And of course, SCI also has the guideline and how to do it. And of course, the preliminary value preserved through the SCI website.
Alright, so it actually depends on the system as well, on your unit system as well, right? So can discharge superheat control concept applied to rotary compressors? It's kind of like a consequent question, so please.
Well, interesting question. About the discharge superheat control concept is to the controlling method to optimize the flow of the evaporator for the rotary compressor is absolutely yes. You can apply too, but it has a point is different between the SCOP compressor and twin rotary compressor. For the SCOP compressor, it will have the high discharge superheat value more than the rotary compressor.
Alright, yeah. Thank you for the clear answer on that. So let me check the next questions. Oh, this one I think is really useful. So if someone needs to use the discharge superheat control, so where should they install the temperature sensor? On the pipe, on the system, on the unit installations?
For the temperature sensor, it should be installed at the discharge pipe. The range is no longer over than 150 mm from the compressor shell. And the reason is we would like to control the performance of the compressor. That's why we have to control the outcome of them.
Alright, that is quite clear. That is quite clear, and we have the exact value to indicate where to install it, so no problem. Alright, let's move on to another questions. And okay, this one will be something different, not the discharge control. So it's about the jacket. And alright, at HCI compressor is a hot shell type. So how high the temperatures that the jacket can withstand? And plus another questions, and it is fireproof.
Well, we design the jacket follow the compressor temperature limitation. In this case is around 120 Celsius. And we also consider about the flammability issue as well. We have the certification, the UL certification, which can use for A2 and A3 refrigerant.
Alright, I think it will cover like almost all the actual conditions. I mean, in the real conditions, it will cover all of that. Alright. So, okay, the last questions here will be about the piping. So someone is curious that why do we have to concern about the resonance, and if it is our concern, so how to deal with it? I mean, how can we work around the resonance?
Okay, a compressor is one of the parts that can move in the refrigeration system. When the compressor moves, it can generate the vibration, and it can make the pipe or some equipment in the refrigeration system has cracked or breaking down. And in some operating range of the compressor, it can reach the natural frequency and then multiply the noise, and pipe can be cracked as well. For how to check the resonance, you have to vary the speed of the compressor for the whole operating range, especially for the inverter compressor, which has the wider range of operating. For SCI compressor, it starts from 15 up to 120 RPS roundabout, and then you measure the vibration and strain, and of course the result of both must not be over than the Mitsubishi criteria.
Right. So it's part of the reliability, and we have like all solutions for that. So don't worry, right? Yeah. So thank you for all your answer. I think it's very clear and give a lot of useful information that will cover like almost areas of the discharge heat control. So thank you again. And again, guys, if you have any further questions, just type it in the live chat, and there will be a specialist standing by to answer all your questions. So see you with the next presenter.
See you.